Hi everybody, this is a video for Math 180, and this is sort of a follow-up, something I did in class, but it's this idea of how to use paper folding, sometimes called origami, to make a parallelogram. Okay, and this is actually a piece of origami paper. It's kind of like wrapping paper. So the idea is the first thing we need to do is make parallel lines. So any fold of the paper, it creates a straight crease that we can consider to be a line. And notice that if you crease it, then it's fairly easy to just trace along the crease with a marker or whatever. Okay, so that's a representation of a straight line. And now the idea is, how do I get a parallel line? And the technique is to use the following sort of intermediate step. Fold that line that you made on itself. Now this fold I'm not going to color in because this is just an intermediate fold. But what we notice is that when you do that, when you fold a line onto itself, the line, the crease that you produce is perpendicular. It forms a right angle with the paper that you started with. How could I test that? Okay, well, the edge of the origami's right angle. So you can see it works real nice. Okay, so now I've got my line and I've got a perpendicular line. And basically you fold the perpendicular line onto itself. Now, for me, sometimes I need to just make a little mark here so I kind of know where that edge is. Okay, so, and you can, depending on where you put it, that's where you're going to get your parallel line. So let's put it like right, folding that line onto itself. Sorry, I got to get closer to be accurate. Okay, and then when I make this fold, second fold, that's going to be a line parallel to my first line. So let me color it in. So these two folds are parallel to each other. Kind of cool, huh? I've got make a fold anywhere to get a straight line, make a perpendicular fold to that line, and make a perpendicular to your perpendicular. So a line that's perpendicular to your perpendicular is, here I'm going to draw this in, just normally I wouldn't do this, but here's the perpendicular line. So this is 90 degrees and this is 90 degrees. So these two guys are parallel. Okay, so that's basically how you make parallel sides. Now how do you make a parallelogram? Well, you just do it again. Pick your line, your starting line. And then make a perpendicular to that line. So fold that line onto itself. That makes the perpendicular, which I'll dot in. Okay, and now here I'll mark that on the edge. And then you fold that line onto itself. And when you do that, notice you get this shape that's a parallelogram. So let me put the vertices in and maybe, mark it A, B, C, D. So A, B, C, D is a parallelogram. Now it kind of looks like it's a rhombus. All four sides are the same. But I don't know. I didn't construct it. I didn't force it to be a rhombus. Okay. So you can use this method, like let me do the same thing, to make a general parallelogram. So this is, so let me go over on the side here, on the paper side where it's pretty. This is my parallelogram. And the thing that I like about this method is you're actually using the standard definition to create the object. You're using parallel lines. So you have two pairs of parallel lines. Now, once you've done that, you can explore other properties that a parallelogram has. Right? Like opposite sides are the same length, opposite angles are the same angle, adjacent angles are supplementary. So there's a lot of other things you could do. And if you wanted to do something kind of fun, highlight your parallelogram just with some origami ideas. If you fold in your corners. So all I'm doing is taking those folds that were the parallel lines and lining them on top of each other. And that's a way to make your shape kind of more 3D. You'll, hopefully you'll see when I finish. So this isn't so much. This is the origami sort of side. So that's kind of cool. I made sort of a nice paper model of a parallelogram. Okay, and that would be the first step of making sort of, a 3D shape with origami. Okay, so while we're at it, let's think about a way to make a rhombus. So we could make a rhombus using this idea, but we'd have to make sure that all four sides are the same length. And that would be a little bit more difficult. So another way to make a rhombus is to take advantage of the symmetries. So again, one fold is a side, but now this fold that I'm making here is not going to be the side of the rhombus. It's going to be one of the diagonals. So when I fold it onto itself, which I admit I have a hard time doing, especially in this lighting. Okay. Then this is going to be the other diagonal. So these two things here are going to be not the sides, but the diagonals across the rhombus. And to make a rhombus, now I've got this here, and I fold it like this, okay, like that. And then I fold anywhere to make a triangle. Okay, and unfold what I have here, and voila, I think you can kind of see it. It's going to be a rhombus. So my actual shape now, is here, here, and I apologize, I am not the best origami person. I kind of love it for mathematics, but I haven't practiced it enough to be really competent on it. Okay, so this guy here is a rhombus. All four sides are the same length. And I didn't do it from the definition. I did it by a property. And the property that I did is the fact that these two diagonals, which I'll dot in, right, my two original folds, they are, by the way I constructed it, they are perpendicular and they bisect each other. So when you have bisecting perpendicular diagonals in a quadrilateral that forces you to get a rhombus. And you could think of it as later on, kind of in high school geometry idea, the proof is in the fact that, notice you've got 4 triangles that are all congruent by side, angle, side. So that thing you learn sort of this becomes a theorem in high school geometry. So since all 4 of these triangles, let me draw in the triangles. Well, you can kind of see them, but all 4 of these triangles are congruent by side, angle, side. So that means by corresponding side, all 4 hypotenuses have to be the same. And those hypotenuses are the sides of my quadrilateral. Therefore, my quadrilateral has 4 equal sides. Therefore, it's a rhombus. Okay, so this is just a couple examples of using origami and properties of shapes to construct models of the shapes with paper. Thank you.